The SN10 flight test draws near, we review the SN9 test flight, and we take a closer look at current SpaceX priorities. SN9 flight test recap. On Tuesday, February 2nd, SpaceX completed its second high-altitude test flight, the SN9 flight test to 10 kilometers. The launch occurred at around 2:30 CST, and the flight lasted just under 6.5 minutes. As the vehicle ascended to apogee, we saw the successive shutdown of each of the 3 Raptor engines. Upon shutdown of the 3rd Raptor engine, Starship SN9 transitioned into the skydiver maneuver, entering into control fall using its forward and aft flaps to maintain attitude. The anomaly in the SN9 flight test occurred as the vehicle attempted to reorient to the vertical. Just prior to this point in flight, SpaceX had already transitioned from the main propellant tanks and was pulling fuel and oxidizer for the Raptor engines via the liquid oxygen and liquid methane header tanks. Again, up until this portion of flight, the SN9 flight test and the SN8 flight test appear to be quite similar. This point in the flight is where things diverged. In the case of the SN8 test flight, fuel header tank pressure was low during the landing burn, causing touchdown velocity to be high and RUD. On the SN9 flight test, on the other hand, according to SpaceX, during the landing flip maneuver, one of the Raptor engines did not relight and caused SN9 to land at high speed and experience a RUD, a rapid unscheduled disassembly. Unlike SN8, which sort of slowly descended and crumpled into the ground, SN9 rapidly lost altitude and slammed into the ground. When asked on February 4th why only 2 engines were lit for the landing burn as opposed to all 3, Elon responded, "We were too dumb." He expanded on the statement, noting that it was foolish of us not to start 3 engines and immediately shut down 1, as 2 are needed to land. This approach adds redundancy. Again, on February 4th, when asked about the possibility of lighting all 3 engines and then throttling down for landing, he stated that this approach would work, yes, but the engines have a minimum throttle point where there's a flameout risk, so landing on 3 engines means high thrust to weight, further away from the hover point, which is also risky. SpaceX will attempt the new approach for the landing maneuver on the Starship SN10 high-altitude flight test, starting the 3 engines and immediately shutting 1 down. Progress on SN10. On Sunday, February 7th, the team in Boca Chica completed the installation of all 3 Raptor engines for SN10. And on Monday, February 8th, SpaceX completed cryoproof testing with Starship SN10, filling the tanks with liquid nitrogen. With cryoproof testing successfully completed, SpaceX will now move on to wet dress rehearsals and then proceed towards static fire tests. An initial TFR was issued this week, but has now been removed. It now looks like that SpaceX may be targeting as early as next week for the flight test. It's also worth noting that the FAA also has to authorize the test. Shortly after the SN9 flight test last Tuesday, the FAA noted that it would oversee an investigation on the flight. We await official word from the FAA on the status of the SN9 investigation and on SN10 flight test approval. Starship data points. SpaceX's first high-altitude flight test, the SN8 flight test to 15 kilometers, occurred on December 9th. The second high-altitude flight test, the SN9 flight test to reduce altitude, 10 kilometers, occurred on February 2nd, so the first and second tests were about 2 months apart. Based on how things are shaping up so far with SN10, it looks like SpaceX could potentially improve upon the 2-month turnaround time between Starship high-altitude tests. SpaceX has improved on a number of aspects of the testing process. They've pretty much nailed down cryoproof testing, and since the SN8 flight, they've ironed out the approval process with the FAA. This, of course, is still iterative testing and things can go either way, but the odds seem good, for now. On to SN11. SN11 stacking is now complete. Over the weekend on Sunday, February 7th, the SN11 nose cone was stacked on top of the tank section. We could expect the transportation of SN11 to the launch site in the coming days. SpaceX has made significant progress in the past few years in terms of Starship development. And with high-altitude suborbital flight tests now underway, a question that naturally follows is, how soon for flight tests with the Super Heavy booster? And how close are we to those orbital flight tests? Well, when asked on Sunday, February 7th, What SpaceX's biggest priorities with Starship are right now, Elon highlighted 3. The orbital launch tower that can stack, enough Raptors for the orbit booster, and to improve the ship and booster mass. SpaceX's final design of the Super Heavy booster is expected to utilize as many as 28 Raptor engines. On booster prototypes like BN1 and BN2, however, Elon has stated that SpaceX will only utilize around 2 to 4 engines. This will be done to minimize engine loss in the event of any anomalies during flight tests. Raptor engine SN50 has just been installed on Starship SN10. In order to support initial flight tests with orbital boosters, or even to support multiple orbit boosters in general, SpaceX is definitely going to have to ramp up Raptor engine production. Orbit launch tower. About a month ago, Elon revealed SpaceX's insane plan, insane in a good way, to catch Super Heavy boosters with the launch tower arm. Catching the Super Heavy booster with the launch tower arm eliminates the problem of engine loss in the event of an anomaly. Maybe this is why the OLT is on SpaceX's top priorities at the moment. It's an idea that's been suggested in a post by Reddit user McElmark. Of course, catching a rocket booster with a launch tower arm is a totally unprecedented move, so it comes with its own host of challenges. OLT also eliminates the need for landing legs, another potential way that SpaceX could achieve goal number 3, reducing the mass of the rocket. SpaceX has just stepped up the game in terms of orbital launch pad construction, and is now pouring more concrete at the site. In terms of the third point, reducing mass, SpaceX is expected to gain some data points and insight from SN7.2 testing. The tank passed the initial pressure test back on January 26, and on February 4th was pressurized to failure. SN7.2, unlike its predecessors, utilizes 3mm stainless steel as opposed to 4mm stainless steel. Other Starship prototypes. Elon has stated in the past that major upgrades could be expected from Starship SN15 and onward. It's not quite clear just yet what these upgrades are. SpaceX continues making progress on other Starship and Super Heavy prototypes. The SN18 forward dome was spotted last week Thursday, and on Monday of this week, the Super Heavy BN1 aft dome was sleeved.